Hello again, I am Emilio and now I will present the final experiments designs for my project Drum Boiler Optimization Parameters and the results obtained. Follow me through this research. This is a drum boiler. This is a drum boiler. It is a standard feature of water tube boiler. The drum stores the steam generated in the water tubes and acts as a phase separator for the steam-water mixture. The experiment I have in mind is to find the most efficient algorithm to optimize the time of the operating sequence for the startup of a drum boiler. The startup of a drum boiler can be formulated as taking the system from an initial state to a goal state in a minimum time while satisfying a number of mechanical constraints. The initial state in the drum boiler at a certain point full of water, and the goal state is the drum boiler with a certain local pressure and steam mass outlet flow. This steam can be used in a thermal power plant, for example. To make the optimization of the drum boiler as efficient and effective as possible, 3 metaheuristic algorithms with 2 different initialization parameters were evaluated. To make the optimization of the drum boiler as an optimization problem, there are some influential variables to take in account. First, the simulation model. The fidelity of simulation model of the system is an important variable in the results obtained. If the simulation is not reliable, the results will be unuseful. For this project, the simulation model is based in a nonlinear physical model proposed by Astrom et al., and the simulation model is coded in Modelica language in the software OpenModelica. This simulation model is the one proposed by Belkir et al. Now, the solution representation. The representation of the operating procedure is an important variable. For this problem, the solution representation of the operating procedure can be defined as a finite vector with 3 discrete values each element, a tuple of operation and time, and a repetition element. There are 9 operations, with each operation being a combination of discrete values of each operable valve. The time element is discretized in values of 60, 120, and 180 seconds, and the repetition element in integer values between 0 and 9. The optimization algorithm to find the best operating procedure sequence. For this case, we will use metaheuristic algorithms, which has 2 important features, exploration and exploitation. Exploration means generating diverse solutions, usually by randomization, to explore the most possible the search space of solutions, while exploitation means focusing on the search in a local region when a good enough solution has been found there. The combination of these characteristics makes metaheuristic algorithms a suitable option to find a good solution in a reasonable amount of time for large-scale, non-deterministic optimization problems. Finally, the optimization algorithm parameters. The optimization parameters being the most important, the initial solution or seed. In other words, where do I start searching? The purpose of the study is to find the combination of optimization algorithms with optimization parameters that could find the best startup time in the best computational time. In other words, the most effective combination and the most efficient combination. The experiment consists of the evaluation of two qualitative variable factors. The first factor will be the algorithm, and its three possible variable levels are hybrid algorithm, simulated annealing algorithm, and taboo search algorithm. This factor serves to analyze the performance of each algorithm in this problem. I will use two dummy variables that allows to represent the values of the three levels for the algorithm factor, with being the combination 1 and 1 the hybrid algorithm, -1 and 1 simulated annealing algorithm, and 1 with -1 for the taboo search algorithm. For this reason, the interaction between dummy variables are crucial for this experiment. The second factor will be the initial solution, or SIT, and its two possible levels are randomly generated initial solution, -1, and reference feasible initial solution, +1. This factor will be used to determine if there is a substantial difference in the ability of each algorithm to generate a good result, either from a random initial solution or a reference initial solution. The mean of 10 experiments will determine the outcome variable, and the simulation model and solution representation remains fixed. This experiment will be run using a computer interface. For this reason, there is not much concern about the appearance of disturbances in the experiment. However, the computer in which the experiments are carried out could be considered a covariate. For this reason, all the experiments were always carried out on the same machine. To do these experiments, I will use the full factorial design, and the reasons are: the interaction between the dummy factors and the optimization parameters is crucial to understand the effect of each algorithm. And also, these experiments will be conducted using a computer. For this reason, the use of the full factorial design can be considered without representing an excessive cost for the project, even considering that each experiment represents 10 runs of each case. The following tables show the results obtained from the means of the 10 experiments in each of the cases in a standard order. With the experiments run, the following models were generated. As it seeks to minimize the result of both models, the following conclusions were reached. For the startup time, the independent effect of the seed is minimal. However, in the case of the dummy, the combination +1 and -1 respectively, which correspond to the taboo search, is recommended to minimize the result. Regarding the interaction of the dummy with the seed, the effect is considerable, and analyzing the signs of the effects, the combination of taboo search with feasible initial seed is recommended. For the computational time, here the independent effect of the seed is greater, and it is recommended to start with a random seed. In the case of the DOE effects, the combination +1 respectively, which correspond to the hybrid algorithm, is recommended to minimize the result. This time, the effect of the algorithm is very large compared to the other effects. So the recommendation to minimize the computational time is use hybrid algorithm with randomly generated set. Thank you for your attention.